First of all, thanks so much for having us here. My name is Eduard Marfà, and I have the pleasure of having Jacob with me.
Hello, everybody.
And there are going to be two companies presenting. I'm representing Siemens, and Jacob is representing Blendhub.
I'm from Blendhub, yeah.
Yeah. And why these two companies together? Well, with Blendhub, we found a lot of synergies during all these years. As you could see, there's a lot of different subjects that we are doing together. And we have a lot of R&D together, and we're exploring some of these areas. That's why we thought it would be interesting of having both on stage today.
Absolutely, I think it's an amazing opportunity to share and showcase the combined strengths of both Blendhub Group and Siemens. I think it's all about, for us, it's all about reimagining the food industry, an industry that is complex, that is stuck in sometimes in technology adoption. So it's really about accelerating and bringing the power of both companies to an industry that's quite fragmented, and I think an industry that needs certainly a lot of technology to bring it into the next era of industry.
Today we're going to talk about these four things. First of all, why it's interesting to invest right now in artificial intelligence and industrial metaverse. What is a little bit about that? Some examples. We'd like to show you with examples that we've done at customers, so not just theory, but things that we are doing right now with some customers. Some examples on artificial intelligence that we have in production, some examples about the industrial metaverse, and then at the end we would like to end up with some clues, some ideas that we can bring to the CEOs on what we see, what is happening, why adopting these technologies is challenging in some ways, okay? So let's get started. I'm sure you've seen a lot of data around about artificial intelligence, industrial metaverse, and so on. You've seen things like this, right? That it's a huge market, that there's a lot of, okay, good. This is a little delay between this and this. Okay, good, perfect. And there's difference between these two. Can you synchronize those, please? There's a difference between there's a big investment in this area. For me, and I think we discussed that with Jacob very much, is that there's a new language that we need to learn. That's a new language that IT needs to learn to talk with machines, to talk with systems, to talk with their factories, to understand what is happening.
Yeah, absolutely. Eduard and I were talking a little bit about how do we think about technology adoption, and my personal story has a lot to do with language. My name wouldn't suggest it, but I come from Murcia, so a little bit of an atypical place with such a name. But my background is very multicultural, and I think the world in general is becoming very multicultural. So we've learned languages to communicate across different backgrounds, different cultures. And I think it's no different with technology. My personal experience was when choosing what to do in terms of back then at a university level. The question was learn more languages or learn the technology that is actually connecting beyond boundaries, connecting beyond cultures. And I think a lot of people forget that today technology, knowing about computers, understanding what is behind everything that we're doing, is table stakes. I think not just for people that are involved directly in technology every day that are behind or responsible, but I think everybody involved in management and all across the company need to be able to talk about this language.
Yeah, but we've seen that there's a new way to talk with machines. You know that artificial intelligence systems right now, they are systems that they are able to perceive the environment, they are able to learn about what is happening, but they're able to understand and learn about how to improve these processes, right? But there's a big difference between what we have in a system, but also what we have in a regular environment in an industry. So everybody, when we talk about AI, they have in mind always ChatGPT, all these chatbots and so on. There's a big difference between a system you can have in a commercial or in a private place, and the system that you need to use in an industrial environment. First of all, the amount of data that we have to manage, the amount of data, the confidentiality of these data, the risks that we are occurring when we use these systems, And just to give you an idea of the amount of data that we manage, with Siemens, you know that we are an automation provider. One of every 3 machines runs with our controllers. So we manage a lot of data. Just to give you an idea, we manage about these 100 terabytes every hour, which is the equivalent of all the Netflix catalogs everywhere in the world every hour. That's the amount of data that our systems have to manage, okay? And there's some areas where we see that AI is applied right now in industrial environments.
Yeah, absolutely. I think, like you were mentioning, a lot of people think ChatGPT, how's that going to revolutionize the industry? And I think there's certainly a lot of cases, but I think there's also a lot of interesting applications around visual quality inspection, anomaly detection, process optimizations, quality predictions, and quality especially I'll go into in a few slides as well. But I think there's an enormous opportunity, and really it's about getting close and defining the use cases that really can bring the most value to industry, really the quickest turnaround, and start with the low-hanging fruits and really jump to revolutionize the industry.
Let me show you a couple of examples. One, as an example, with one of our customers, with Renault Nissan. And one of the things that we did with them is to create what we call virtual sensors. In some environments, when you have to put a sensor to detect temperature, weight, or any kinds of things, you would like to put it in a place that it's very difficult because they have to be in high temperatures and so on. So as an example, I had this discussion with Iñaki Ulizar that I see here when he was at ITP about where to put sensors, and they say, yeah, we would like to put sensors inside the aircraft engine when we have thousands of grades of temperature, so it's impossible to put a sensor here. That's why we create these virtual sensors. So using AI and using our simulation tools, we create these virtual sensors that they behave like a sensor. We put those inside the engine. It's an electrical engine or a power engine, and you can detect and you can know the behavior of these engines. That's one of the examples that we do. Another very classical example is visual inspection. In the electronics, when you would like to inspect these PCB circuits, is something you cannot do visually because there's the speed of these circuits when they go into the line is very, very fast. Even some laser systems, they do a lot of fails. So it's a lot easier just to train an artificial intelligence system that can detect and predict what is happening. So there's some examples. And of course, there's the big gains in these 2 examples, but I would like to show you, or ask Jacob, how do you do it at your company, Chemometric Brain?
Absolutely. Absolutely. So just as a short intro, maybe Blendhub Group and Chemometric as one of the spin-offs. Blendhub is a global manufacturer of food powder blends, essentially helping companies from idea to market launch, leveraging a network of production facilities. So instead of the big centralized factories, put the factories where they make the most sense, right? Food industry is a highly globalized industry that is buying ingredients all over the world. And so one of the keys is really getting close to where the source is or getting close where the end consumer is. So we're not moving stuff around, right? So one of the key ideas is always for Blendhub as a company is empower small, medium enterprises to go from idea to market and be competitive at a level where other companies are, or where large industrial companies can also be, right? And that's where the connection with Siemens lies. With Chemometric Brain, we are a spin-off. We're a company that's focusing on quality, and we're really looking at the food industry from the perspective of what are the challenges that we face in the industry. Supply chains, as I mentioned, are global. It makes it really tough to really track and monitor across the world the quality and ensure that it's consistent. Consumers are becoming more and more demanding as well. They want quality products, they want transparency, they want supply chain visibility, and companies need to deliver this in a way that is doesn't kill profitability, right, or doesn't hurt profitability. Technology adoption is tough as well. It's really the food industry, about 27% I was reading of companies only are using smart manufacturing in this industry. No. So it's an industry that has some challenges with technology adoption. And then one specialty that is close to us that a lot of people forget about is fraud. There's about $50 billion every year of fraud in the food industry. And it's a challenge that's really tough to fix because the guys that are going to trick you, they're always coming after you, right? And that's one of the key challenges. So the quality systems in the food industry, they rely on trust. So I've been buying from the supplier for years. They've never failed me. They won't fail me now. Of course, they won't. It makes you a price taker, and it really puts you under pressure and a high supply chain risk in industry.
I love this picture when Jacob was telling me that the processes haven't changed. This picture from a lab for testing food. in the 40s and the
Yeah.
lab in the year 2000,
It's exactly the same.
it's the same.
Yeah. And so that's one of the key challenges, right? We talked about IoTs and we talked about things, but in the food industry, much of what goes on in quality is still very much relying on sending samples to a laboratory and getting results after a couple of days. And that's not really good for releasing a product that is perishable and that needs to go to market quick. So for us, in an ideal world, we really track, test, and trace everything from raw materials to the processes that nobody ever makes a mistake in until they do, and then come the madre mias. And then the product as well, right? Checking really the final product, not relying on a lab that is expensive and takes days, but really something that can be done in the moment, right? Decisions in the moment. And so what we're doing is we're talking about artificial intelligence, we're training machine learning models for two types of applications. We leverage the technology that's been around for a long time, that leverages light to actually get a chemical fingerprint of a product. And we leverage it for two types of applications. We train models that give you everything from the protein to the vitamin content on a prediction in a few seconds of any food sample in the world. And we're training models that will also tell you and will give you qualitative results for determining the origin of a product, determining fraudulent products, and detecting all kinds of issues like that in the food industry. And I think there's a few interesting cases that we have in the next slides to showcase those examples. So we're talking about powder blending. Powder blending is essentially combining different ingredients to do different functions, and it might be everything from your cousin who's buying a lot of the shakes and is getting really buff and is buying milk proteins, and I'll show you an interesting example about milk proteins, to all kinds of products like bakery, like the stabilizers in food products. And you've got a global supply chain where you need to track everything that is coming in. So we're using that chemical fingerprint to ensure that batch after batch, you're training models that tell you exactly what's inside of that product, and that tell you that that product is consistently the same over time. It also gives you the opportunity to compare different suppliers. Blending is also an interesting example, and we have a few opportunities. When we talk about raw materials, the dairy example is one that is interesting.
Yeah, he was asking, he was showing me this picture, I think, a few weeks ago, and I was asking him, what is this?
Yeah.
And he told me this is a picture of fraud.
Yeah.
Food fraud, protein,
in dairy,
right?
in this case. So in the food industry, if you test, this is an image of a model trained on samples of milk protein concentrate, so the stuff that all the gym guys are having. If you adulterate that with some other source of protein, it might be a whey protein, or it might be something more harmful, like you might have with the melamine case in 2008, where babies were poisoned in China. It's really tough to know what to test for, because if you test for protein, you're going to get the right results. What we're doing by using the fingerprint, and what you can see on the screen, are samples that have been adulterated everywhere from 10 to 1% with different sources of protein. And what you can do in a few seconds is, without knowing exactly what you're testing for, know that that sample has a deviation, and from there, spend the resources and the time investigating those samples that are suspicious instead of testing everything.
And this type of fraud is typically undetectable if you don't have systems like the ones
Absolutely.
you designed,
50
right?
billion is an estimation. I think we're probably far beyond that in the real industry. And another interesting example that hits close to home as well, for example, Iberian ham, jamón ibérico, is another industry that is very traditional.
They are testing pigs, yeah.
Yeah, absolutely, and live ones too.
Alive ones, right?
Yeah. It's interesting, but our industry needs better technology. So when you have a pig on the farm, and there's a very big difference between eating acorns or eating feed, and there is no good ways today, or there is good ways, but they take a long time. What we've developed is a solution that will give you the ability to determine if a pig has eaten acorns or has eaten feed, and that changes drastically how the manufacturer can ensure that what they're buying is what is supposed to be, and also that the quality that comes out of the production is exactly what it's supposed to be. So then, when consumers, and picky ones at it, taste the final product, they know that they're getting the real deal, and that complaints aren't going to come in. So, yeah.
It's an amazing example of how AI can help just to design systems that they were impossible a few years ago. So that's a good one.
Absolutely.
So let's move to the next subject, the industrial metaverse. So I'm sure you've seen or you heard about a lot of the industrial metaverse, what it is, what is used in games, what is used in real life. But I don't know if you heard about how can we use it in the industrial environment. And I would like to show you some examples, but I'd like to tell you a little bit, first of all, what is not. This is not virtual reality. This is not augmented reality. It's a little bit more than that. It's not just an environment where we have nice renderings and images and things like that. Basically, when we talk about industrial metaverse, we talk about this environment where we can bring things to life. when we can test anything that happens in our products, anything that happens in our factories, just to make sure that we have a correlation with the real world. And we're going to show you some real examples. But first of all, the building blocks. The building blocks of an industrial metaverse, we think that are these four. First of all, having a robust digital twin. Digital twin of your product, digital twin of your system, digital twin of your factory. You will see some examples afterwards. Then, of course, these systems or these digital twins have to be synchronized with environments. You will see some examples later on with about some ships and how these ships are sailing in the sea and how the sea has interaction with the environment and so on. That's an important thing. The third thing, we need to have this system enabled with AI because we would like to do things in the industrial metaverse. We would like to test things. We would like to try things. We would like to see if what we're testing in this environment has a correlation with the real world. And the last fourth thing, of course, it needs to be a platform where we can plug different systems and different data coming from different sources. You will see how we're talking about. And as we say at Siemens, we are always customer zero. We test these things in our factories, we test these things in our offices. And we've been using industrial metaverse in some of our factories. This is one factory in Erlangen where we produce some of our PLCs, and we have different use cases. So we use as an example the industrial metaverse just to train the workers, to work on the layout of the plant. Also, we use synthetic data to train some pick-and-place robots that we use, so that's one of the examples. And also optimizing operations. That's are the things that we do, and we tested this since 3-4 years ago in the industrial metaverse. So basically, this technology that helps us to transform what we're doing, okay? But we're gonna show you one example that we just did recently. That's very, very fresh thing. We just did it in the last 2 months with Blendhub. And we just thought on an idea on how to solve a problem that happens in the food and beverage industry, especially in the beer industry.
Absolutely.
Yep.
30 billion kilos of beer strength that go to waste every year, or to waste either go to worse sources, or they go to animal feed, or they simply are rotting away someplace where they're creating a lot of emissions and not really going to create the value and from the protein and the fiber that is in the product as well.
Yeah.
Huge issue.
And it goes in along with sustainability. The idea is that, okay, after brewing beer, companies, they just buy really, really expensive grains, really, really expensive products to brew the beer. They brew the beer, what happens with it, what is left in the tank? What happens with all these ingredients? That they're perfectly good. Most of the times they're just used as bioplastic fuels, burned, or given to animals. But they are perfectly great ingredients that we could use to do other products. Absolutely. And we thought, okay, let's make an exercise and see how can we do an upcycling of these products and create, as an example, a cracker based on this grain, okay?
Absolutely. I think a lot of people forget that a lot of the waste cycles are interesting streams that then come back to our food system. So we stabilize our marmalades with the skins that after you press the juice from the lemons, you take the skin, you extract the pectin, then you make a jam with it. So there's so many interesting sources of food, and it's a shame that they end up going back as a great protein source, that they go back to an animal source where it's a lot less efficient when us humans can consume it directly, right? So when we think about also this, we talk a lot about going in a more sustainable way in the food industry. This is really a lot of the good ways to do it. We don't really need to be eating fancy, complex burgers from weird sources. When we have a lot of good sources of ingredients as well. And I think that's one of the key things that Siemens and Blendhub are collaborating on, helping companies bring these types of products to market. And I think the example is stupendous.
And that's our challenge, and I would like you to follow us in this story. So we would like to start from a new recipe for a new cracker, and then turn it into a final product.
One of the key issues in the food industry is cycles for innovation for a product are extremely long. I mean, we're talking about a year, 2 years, really long cycles, and most of it actually is shelf. Most innovation in the food industry, 95% of it is shelf, never actually reaches the market, right? So one of the key things that Siemens and Blendhub are working on together is really quick cycles of innovation. We're talking launching products in 90 days, 60 days, 30 days, really iterating fast, like we've done in the world of software, in a way that the food industry can start to adapt and create culture with recipes that are integrated throughout different stakeholders as well. But I think is one of the key issues, right? Bringing all the people around, the guys that are making the beer, the guys that know how to formulate crackers, the guys that have all the expertise around the table, and the guys that can manufacture the products as well, right? And I think that's one of the enabling things that Siemens is doing.
Yeah, and that's what we ask ourselves. Okay, how can we speed up this process? How can we create virtually a system or a factory in the metaverse that help us to test all these recipes? That this recipe that we just created for this new cracker is going to be able to be produced, and how and when and how long and how feasible is to do this production. Absolutely. And that's more or less the process that we are doing. That's a classical process in this case in the beer industry. From the leftovers of the tank, you dry those, you grind those, and then one of the cool things about Blendhub and Chemometric brand is that they produce food. They created, as you see here on the corner, they created these micro factories, these portable factories that they blend different powders, which is the base of our crackers. Absolutely. And then we did it, okay, just to finish the recipe, we put this, we add it into our flexible factory in the metaverse. So you will see we have a fully automated factory that has no pipes, no workers, and everything goes with AGVs, with drones, and you will see how the drones know how to execute the recipe. And at the end, we will have this new product that we can test in the metaverse. We can test that it works, but also everything that you're seeing is connected to all the manufacturing systems, is connected to the AGVs, is connected to the world. So let's try to get started with that.
Absolutely.
And that's an example that we did for another customer of our factory. One of the key points on the food and beverage industry is that most of the factories you see, they have a lot of pipes. Cleaning up the pipes is one of the biggest issues. A few years ago, maybe a couple of years ago, we designed a factory for food and beverage without pipes. We call it the pipeless factory. And we presented that to some customers, and we told them, yeah, in this factory, you can do shampoo and mayonnaise at the same time, in the same resources. And we have these AGVs that they know their recipe, they go around, they create all these things, they know their path, and you will see one example of that with a cracker. We're gonna make some crackers. How do you make crackers? Well, basically, that's a very simple process. You're cooking, so we have some base premix.
The same stuff we all do at home, but
yeah,
at a big scale.
Yeah. Then we add some flavors. We had some garlic, some flavors, and so on, which is important. So Jacob's going to tell you why is this important. And then we go with the liquids. And for these crackers, we have some water, some olive oil, and then we just have to cook it. That's it. And we have some crackers. That's a little bit the recipe. And this is how it's running in Blendhub's PBB. We call it the microfactory. The first thing we're doing is creating this premix.
Absolutely. I think one of the key things is and all these premixes, one of the interesting things about being able to fast iterate is you can create and adjust the recipes based on different tastes, different local flavors and needs. And so here in this example, a small premix of the bagasse is prepared, and that can be then delivered to add and dose the different flavorings, right? That can be adjusted based on different needs in a much more personalized way, right? In the direction that the food industry is going, that is much more personal, much more niche, where different countries, different regions all have specific needs and interests.
And one example here is that we're connected their hub in the factory, but also we're connected with our simulation tools from Siemens, so we can know how this bagasse is going to be mixed. What you're showing here is a real simulation of the different powders of this premix. We're checking speed of mixing, when is going to be good, and so on, just to create this powder mix.
One of the interesting things about powder, and maybe it's a little bit of a nerdy fact, but I certainly enjoy it, I think is that unlike when you mix something in water, powders don't actually mix homogeneously. So you can actually blend and then de-blend the product by actually continuing to blend. So it's not as straightforward as saying, okay, let's go 8 minutes and that's going to work. And so that's one of the key things that both on a simulation level we can check, right, using the Siemens system and the simulations, but also using Chemometric Brain, we can verify once you're in the manufacturing process that exactly the composition of the individual parts of the batch are exactly what they're supposed to be. So you optimize time and you give customer a consistent product across the board as well.
And this is how the factory looks in the metaverse. And we're going to ask one of these AGVs to run the recipe. You see step by step how it's going to happen. And we call the AGV, and the AGV knows that he has to create some crackers. So the first thing he needs is to go to the first station and needs to ask for a container. Talks with the robot and says, what do you do? I put containers, so I want a container, just put a container on me. And we have the container. And the first thing that he needs to do, because he knows the recipe, is to go to the hub from Blendhub and load 10 kilos.
Absolutely. Once the blending process is finished, so you load the product, and then you've got a perfect product ready to toast the different flavors, right?
Yeah. And then the AGV goes to the next station, which is the hub from Blendhub, and tells the hub, okay, what do you do? I have this powder. How much do you need? 10 kilos. Loads 10 kilos of the powder to start the recipe.
10 kilos sounds also like something trivial, but ultimately in industry it's also complex, because normally you're working with very large batch sizes, so there's very little flexibility. But with food that is actually perishable, it's interesting to really be able to work in a much more flexible way, to be able to deliver in a way that you're making micro adjustments that are much more flexible for supply chains, customers, when it's retail ready, and so on.
Now we're going to complete the recipe. And the next thing is just flour would be a really bit boring. So let's spice it up with some different spices and flavors and so on. And we're going to the next step. We have this robot that we call it a microdoser. So it's like a barman that has all the different spices, ingredients, vitamins, and so on. And he's talking with a scale, and he's just putting these 2 grams of garlic, 20 of rosemary seeds, and so on. And an important thing, this microdosing is an important thing in the process.
Yeah, absolutely. If you get too much spice in, then Eduard won't like it, or you get it something wrong. It really makes a big difference, and ultimately consumers, although we always end up eating it, there is a lot of complaints, and so you have to make sure that you're really dosing the exact amounts.
And also for some ingredients, it's really important that you get the right thing. So what you see here is not just the AGV with the recipe, it's the AGV talking with the robot, talking with the scale, and knowing exactly what they are doing, just to continue with this microdosing.
Especially as we go to personalized nutrition, where people might want some vitamin C, or they need some vitamin D in the specific products, and we're seeing it in a lot of different products. So you're really going to start to see also what people are calling food as medicine. So you start to have the ability to adjust as well, and that precise adjustment gives you the opportunity to use it exactly for that purpose. And
let's go with the look. Let's start with water. We have a doser that has 2 columns of water, cold water and warm water, so we get the right temperature. And now we're going to get 1 kilo, I think 1.7 kilos of oil. And that's it. We've finished with all ingredients, and the next step is to mix those. So it talks to the next station, and the next station is a mixer. And it talks to the robot and says, okay, what do you do? I mix things. Okay, what do you have? I have a mix of powders and liquids. So then you need this mixer. I put this mixer on top of you, and I mix it for how long? I need to mix it for 3 minutes. These are all the conversations that these systems are having in real time to produce these recipes. And we do this in food and beverage, you see this. We do it in electronics. We do this customized and recipes or production processes on the fly, just to show how flexible this factory could be. You can think that the next AGV is running a different recipe, is running a different combination, but by testing these things in an environment like this, we can know that this production process can be done, how long does it take, and how much it is, okay? Other environments, moving from another industry, and I'm gonna show you the evolution, okay? We start from the classic CAD, the type of visualization interactions you can have in a classic CAD, and then moving into, as an example, a more enhanced environment when we see simulation-driven visualization, where you, as an example, we can test in this ship how the lights and how the temperatures, or combining this with CFD. So we see this ship, how it's interacting in this case with the sea. So we see not just the waves, but also we could see, as an example, this CFD simulation that tells us all the turbulence, all the different drag, and so on. So you see how this technology is helping us to test things in the real world. And the latest thing we've done, and this is from last month, that's high-end level visualization. This is from maybe the biggest yard in the world. That's Hyundai Heavy Industries, and that's one of their container ships. No, it's not a container ship, so it's another type of ship. But you see how this enhanced visualization with full real models can be combined with systems for, as an example, simulation, data analysis, and so on. In this case, we're analyzing the drag of the propellers, but with the full model with this high-end visualization. So these are the type of things we could do in the industrial metaverse. Hope you like it. And the last things, how can we leverage all these opportunities? What are the main issues that we see from the point of view of CIOs? Well, that's a clear point. So we had this story from Accenture, this study from Accenture, which is really interesting, and says that 84% of the companies see that there's an opportunity applying AI, applying industrial metaverse. But by the other hand, we see that 76% of them, they're failing. They're failing to implement, to get in production. And we just try to see, okay, which are the major hurdles, the major issues that we see in the adoption of this technology. And basically, the question is, okay, how do you move from a pilot to a real environment, to a real production, to a productive environment? And there are these 4 points, the 4 main areas or the 4 main points where we see that there's some difficulties. The first thing you need a lot of data, right?
Absolutely. And unlike for consumers, everybody's going out and posting their pictures online and putting nice labels on it. In industry, not so much so, right? So we need to generate a lot of data and make sure it's properly labeled.
And the next thing is that you need to be able to train your models. You need to be able to make your models more expert. You need to be able to
give them the domain expertise that general models don't have.
But we've seen that the last 2 are where many of the companies are failing, especially when we need to have the real-time, the closed loop what is built, so making sure that our AI system works exactly like my physical system. And the issue is that this is where most of the value is. So the last 2 points where most of the companies are failing is where most of the value is, okay? And how can we move from these proof of concept, this pilot, to a production environment? So we call it the proof of concept purgatory. There's a lot of issues that are happening. There's a lot of things that are happening in the industry that prevent us to move successfully into a successful implementation.
Absolutely. Many hurdles to overcome. I like the picture with the purgatory. I think it's very illustrative. Ideas are very easy. The initial validation is easy. The execution and the really industrial scale up is the really tough part.
The 2 main building blocks that we think that companies are missing or they're still investing on are, first of all, infrastructure. It's difficult to have an infrastructure where all your automation systems, where all your IT systems are fully connected and enabled for AI. And of course, a really good tool set. Not take ChatGPT, but also tools and applications that they are really capable of managing these amounts of data of what we need.
Adjust it to the specific needs and not a general tool, but one that serves specific needs. Otherwise, if everybody needs to reinvent the wheel inside of every company, then it's going to take us a really long time to really get to the end goal.
And for us, we see that one of the key points is this connection between IT, OT, and edge devices could be or is one of the keys where it's going to help you just to improve in this rate of adoption of AI applications. So we are working, as an example, in edge devices enabled with artificial intelligence, so you can run your applications at the edge level, but also at the control level, and also being connected to the cloud. So that's one of the keys that we would like to give you as the final one. Thanks so much for your time. Thanks so much, Jacob. It's been a pleasure presenting with you.
Absolutely, I've enjoyed as well, and hopefully we've given you a little bit of an idea, and I'm sure we can talk about it a lot longer on the cafeteria or anything else about many of the things with the metaverse, the food industry, digital quality, and all of these different ideas. So I think we're both very keen on seeing what everybody has to say about it.
Thank you.
Thank you, Eduard.
Thank you, Jacob. Thank you for your